Welcome to this explainer. Today, we're diving straight into a massive topic, how the engineering and construction industry measures and manages its really severe impacts on local ecosystems. We're going to look at this specifically through the lens of the SASB standards. That's the framework developed to hold infrastructure companies accountable. If you've ever walked past a huge construction site and wondered how all that environmental damage is actually tracked on a corporate balance sheet, well, that's exactly what we're going to explore today. To make sense of this dense 26-page technical accounting standard, here is our roadmap. We'll start with building the modern world, then look at the hidden environmental toll, tracking regulatory non-compliance, managing and mitigating risks, and finally wrap up with the true cost of construction. All right, part 1, building the modern world. Right up front, the source material points out a massive, explicit trade-off. On one hand, we absolutely need these infrastructure projects, right? We're talking power plants, dams, hospitals, data centers, the literal building blocks of economic and social development globally. But on the flip side, you can't build a massive piece of infrastructure without literally tearing up the earth. The fundamental activities required to build them, things like clearing, grading, and excavation, immediately threaten local environments and surrounding communities. It creates an inherent tension that has to be actively managed. Which brings us to part 2, the hidden environmental toll. When we zoom into the actual site level, construction activities can severely disrupt local ecosystems, and this is a primary focus of the standard. We're talking about direct biodiversity loss the second land gets cleared. You've got heavy machinery kicking up massive air emissions, and excavation work that alters local water flows, leading to some really problematic water discharges. Add in harmful waste generation, the sheer volume of natural resources consumed, and the use of hazardous chemicals. All of these factors create immense environmental risks way before a building or bridge is even finished. The International Sustainability Standards Board, or SSB, expects companies to measure these disruptions with absolute precision. The very first accounting metric under environmental impacts of project development, coded as IFN 16A.1, tracks the sheer number of incidents of noncompliance with environmental permits, standards, and regulations. It gives investors and regulators a hard, quantitative number to evaluate exactly how a company is performing on the ground. Moving on to part 3, tracking regulatory noncompliance. Now, the threshold for reporting here is actually pretty fascinating. Companies have to report every single violation. It doesn't matter if it's a one-time thing, a continuous discharge, or a non-continuous spill. And here is the kicker. They have to report it even if the government hasn't officially fined them or sent a warning letter yet. If a permit limit is breached, it's an incident of noncompliance. End of story. Furthermore, the standards make sure that companies can't just pass the buck. The scope of disclosure explicitly includes incidents of noncompliance by any subcontractors working under their direct supervision. The construction industry relies heavily on outsourced labor and specialized subcontractors, so this rule ensures the primary engineering firm stays completely on the hook for the environmental footprint of the entire site. The standard also gets incredibly specific about what actually counts as a violation. It demands total transparency on things like pumping too much waste into local water, which they call effluent limit exceedances or waste load allocation issues. It covers oil and hazardous substance spills, taking way too much water from local sources, failing to pre-treat wastewater properly, and even violations related to land use and endangered species. It's basically a comprehensive net designed to catch any ecological disruption. Next up is part 4, managing and mitigating risks. According to the second SASB metric, IFEN 160A.2, companies have to perform really rigorous due diligence before the construction even starts. They follow a few core steps. First, assess the baseline environmental conditions so they know exactly what ecosystem they're dealing with. Second, figure out if there are feasible, environmentally preferable alternatives for the project. And third, put a solid plan in place to protect local biodiversity and use resources efficiently. Doing this homework early is absolutely crucial. Then, once the bulldozers are actually rolling, the focus shifts to active mitigation. We're talking about actively minimizing waste emissions and water discharges, but it's also highly procedural. Companies need strict quality control processes right there on the project site. They have to set up strong internal mechanisms for reporting and following up on any environmental incidents quickly. And, critically, they've got to make sure their employees are fully trained on both the regulations and the necessary cleanup procedures. To prove they're doing all this correctly, companies don't just invent their own rules. They rely on globally recognized codes and guidelines. Whether it's the U.S. Green Building Council's LEED certification, the Equator Principles, or the ISI Envision rating system, these frameworks act as established benchmarks. They provide a structured, verifiable way to ensure environmental best practices are really being followed in project siting and design. The SASB framework also totally recognizes that not all projects are created equal. It specifically requires firms to detail any extra policies they use for projects that are expected to have significant adverse environmental impacts. A prime example they explicitly mention is IFC Category A projects. Basically, if an engineering firm is taking on a massive, highly disruptive project, they have to prove they're applying a significantly higher level of environmental due diligence. Finally, we reach Part 5, the true cost of construction. Let's zoom back out to the macro level for a second, because tracking all this data isn't just about checking regulatory boxes. It's utterly critical to a firm's financial survival. Failing to properly assess these impacts doesn't just hurt the Earth, it literally destroys the bottom line. Unforeseen environmental issues can massively inflate operational and capital costs. Noncompliance brings brutal fines and super expensive remediation. Plus, environmental concerns inevitably lead to community pushback and costly project delays. In extreme cases, total project cancellations. All of this trashes a company's reputation and kills their chances of winning future bids. On the flip side, those who manage these risks well gain a massive competitive advantage. So the next time you walk past a construction site in your neighborhood or read about some new mega infrastructure project, I want you to consider this final question. If an infrastructure project destroys the ecosystem it was built to serve, who really pays the price? The SASB standards make it very clear that the hidden cost of our constantly expanding built environment is real, measurable, and deeply material. Understanding how these companies track their ecological disruption is step one in grasping the true price of the modern world.